All right, we just locked it into our brain, but here is a question that would make a great test question. Calculate the scale factor of the following diagram. Express your answer as a fraction, decimal, and percent. Now, I know we haven't done a ton on the Cartesian plane this year, but because this red one does not have the little prime symbols, this is your original. The blue one, you're going to notice, has these little tick marks next to the letters. On mine, that is your new one. Did the shape get bigger or smaller? Bigger. So you're going to expect that the scale factor is more than 1. Now, if I want to find scale factor, especially if it's a written question, I should start with a formula. What is the formula for scale factor? Good. Image or the new one over the original. Now, this is how they make these questions a little bit trickier, is I've placed it on the grid. If I want to count a side length, do I need straight up and down or horizontal lines, or can I do it on a slant? Straight up and down. So if I look at this length right here, this is my only straight up and down length. Would you agree this is 1, 2, 3, 4, 5 tall? The other way to see that, it went from -2 to +3. That difference would be 5. So I would say on the image or the original, it was 5. Does that go on the top or on the bottom? The bottom. On the blue one, it starts at -4 and it goes up to +6. Does anyone know what distance happens between -4 and +6? 10 blocks, very good. Because would you agree -4, it would take 4 to get to the 0. +6, it would take 6. So that 4 plus 6 gives me a distance of 10. Now, if the scale factor is 10 over 5, how could you rewrite that? Yeah, 2 or 2 over 1. Now, this is kind of a weird question because it wants it as a fraction, decimal, and percent. Technically, that would be both the fraction, because 2 over 1 would be the fraction, but we'd write it as 2, and as the decimal. But we can change this to a percent. If that's a scale factor of 2, does anyone know what that is going to be equal to as a percent? 200%. Because percent, you'll remember when I was teaching you French, percent. And cent, just like cents in a dollar, is your 100. So to get from a decimal into a percent, you times by 100. Are we okay with that? Mm-hmm. Okay, moving on. Today is all about similar polygons. Now, similar polygons means I'm taking a shape, I am keeping it the same shape, I am just making it bigger with the scale factor. Okay, so if I give us something to look at here, I'm going to go with a square, just because squares are kind of easy to compare in terms of angles. These two would be similar polygons. Would you agree they're both squares? Can you tell me anything that's the same in both of those? Yeah, so we would say, first thing I would want you to notice, both squares have the same angles. So when two polygons are similar, the angles are the same. Now, did the side length stay the same? No. They all grew, but did they all grow by the same scale factor? Yeah, so what we would say if they're similar, the sides are proportional. And I want you to write the word proportional because I think it's important. But what it's saying is they grow by the same scale factor. Or shrink, I guess. Now, if the sides all grow by the same scale factor, the other word that we want you to see is the idea that the two shapes are the same shape. Agreed? They're just a different size. So when two polygons are similar, they're the same shape. And maybe we just write the size is just different. All right, which means similar polygons have either equal angles is one way we can prove it. If all of the angles are the same, we don't even have to worry about the side length. It's going to be similar. Or equal scale factor or proportions. And sometimes I'm not even going to make you prove it with the scale factor. I'm just going to make all the angles the same and you'll be able to just say, yep, that's the reason. So let's take a closer look at the properties of similar polygons to see if they're the same. Now this one here, you can prove it two ways. I tried to be kind of nifty crafty here. When I have the same symbol on the vertices, it means the angles are the same. Would you agree all four of the angles are the same on the original as they are on the new one? Yeah, so we could say quadrilateral ABCD is similar because, so yes, all of the angles are the same. And there's a couple of different ways that we can, if we couldn't see the angles. So if I show you the angles, would you agree that's kind of the easiest way to compare them? The other way I could compare these is I could look at the proportions. And when I look at the proportions, they should all work out to the same scale factor. First thing I want to do, though, we're going to fill in this little chart here. Angle A is the same as angle what? So A was the same as W. So we're going to write that down here. Boys, let's make sure we're writing this down, please. Angle B was the same as X. And you're going to put kind of that funny little angle symbol in front of it. That means we're talking about an angle. C was the same as Y. And D was the same as Z. Make sure we have those written. Now, we also at that time are going to figure out our corresponding sides. They labeled them differently, but we want to get used to this way of labeling. AB just represents the side that connects A and B. What two letters would be the same or the corresponding ones on the other guy? So I'm getting that W and X would be the same. Are we okay with that? So we'd say AB corresponds with WX. Your box is not yellow, but it's in that second box. BC, so we start with the one that connects B to C, corresponds with XY. CD corresponds with, good. And then finally, DA corresponds with ZW. So we've got our corresponding sides. I want us to do the side ratios. So what you're going to do is we're going to take the side length for each and we're going to see what it equals. What is the side length that is AB? 1.5. So we're going to put that on the top. What is the side length that is WX? 2.1. Can somebody, there's decimals there. I'd like you to divide that for me. 1.5 divided by 2.1. Okay, 0.718, kind of a funny one. All right, let's try it for CD and YZ. So CD is 3.0 over 4.2. What is 3.0 over 4.2 going to be? It's the exact same. Weird. Okay, well, let's do another one. BC over XY. So BC is, oh, did I do that wrong, kids? No, I think we're okay. It's 3.0 over 4.2 again, isn't it? And we just crunched that. So we just crunched it. It makes sense. That would be the same. Do you think the last one will be the same? dA over ZW. 2.0 over 2.8. Okay. What do you think that 0.718 represents? The scale factor. Now we have to be careful. It's less than 1, so would you agree it'd be in the direction of things getting smaller? And what it's saying is each side multiplied by 0.718 creates its corresponding side. If they do it for every single side, what does that tell us?
Is everybody getting that number?
Are we getting someone for? Oh, guys. We should. Better. So we got to go back and switch all these. If I make a mistake and you call it out, I'll give you a chocolate bar. Mrs. Graham called it out, River. Okay. If they are all the same, getting back to what we were doing, would you agree that that suggests us the scale factor was applied to every single side? If the scale factor is applied to every single side, are they similar? Yes. So you might want to even draw it in, just showing it would be applied to every single side. When you have that drawn in, everything written, you can flip the page. Okay. All right. Next one. Some of these are similar. I want to know how you know. Does anyone see, and we can number these if you want. We'll number it triangle 1, triangle 2, triangle 3, and triangle 4. Which two triangles can you instantly tell me are similar, Sydney? Triangle 1 and sorry? Okay. It does look like it's flipped. Now, just because it looks like it, we can't necessarily prove it. There is 2 we could prove. McKenna? 1 and 4. How could we prove that 1 and 4 are similar? Yeah. Would you agree they have identical angles? So you're going to write triangle 1 and triangle 4. Have the same angles, so are similar. Now, 2 and 3, we could take a wild guess and hope that they're similar, but we need to do more than that in math. We got to be able to prove things. So if I look, they don't really look like the same shape, agreed? Could I start to try and figure out like a scale factor maybe? How I would deal with this is if it's the longest side on one, should it be the longest side on the other? What is the longest side on this? 8. What's the longest side on this? 12. So if I was going to compare those, I could say I'm going to do JK over WA, because those are my two longest, which is 12 over 8. What does that give me as a scale factor? 1.5. Now we just compared the two longest. Should we compare the two shortest? What's the shortest on this?
4.
4. What's the shortest on this?
6.
6. Now notice, and sorry, it wasn't JK, it was JF. I put that triangle on top, so we're going to do it the same. And I'm going to say, okay, the shortest was RJ. The shortest here was WK. RJ was 6. WK was 4. Did I get the same value? Now 2 is good, but it's not the final answer. It's got to work for all 3. So I would still compare my third set, my middle length of sides. And I would say, okay, the middle would be RF, if we're going with that one first, over the middle being AK. So 9 divided by 6 is 1.5. What do you notice about all 3 of the numbers? They're the same. They didn't necessarily look the same, did they? It was hard to figure out what side becomes what side, but does it make sense that the longest side has to stay the longest side? So you can combine it that way. So if all those are the same, what does it tell you? They are similar. So number 1 and number 2 are similar because they're proportional. Or we could say because they have the same ratio or scale factor. I should have left us with more room to write all of this in. But does that kind of make sense? Those are the 2 ways to prove it. They either have to have the same ratio or the same angles. Which is the easier one to see? Angles. Okay. Check this guy out. There are 2 triangles here. They are just overlapped. If we were to split them up and rewrite them, you would have that little guy, RXT. You should be writing this. And you would have the even bigger one, which still was the R, was still the, and this was a Z, and this was a K. Not my best drawing. Do you think these are similar? I'm hearing yes. What can you tell me that's for sure the same on them, River? Good. So if I look, would you agree they both have a right angle right there? Do they have another angle that's in common? Yeah. They both have the same angle R. Now, in a triangle, if 2 of the angles are the same, they have to add to 180. Does that guarantee the third one is also the same? It does. So you can label what kind of a symbol do you want to put in the third corner?
A heart.
A heart. I love it. So if 2 of them are the same, then the third one is the same. And we could say they are similar because they have the same angles. when you have that written below, you have 3 triangles. Yeah, I know. 2 of them are similar. We need to prove this and we need to compare them. Yeah, it's going to be a little work. Would you agree it's not a nice one where we have the same angles? Which triangle do you want to start by comparing? DFE? Well, let's just do it triangle 1, triangle 2, triangle 3. Which ones do you want to compare first? 1 and 2. Now, only way to compare is to create the ratios, see if they match. I'm going to always put, do you want to put number 1 on top or number 2 on top? 1 on top, okay? I'm going to start with the longest side. That's 18.5. What's the longest side on the second one? 37. So my longest is going to be DE, because we said that one will go on top, over GI, which is 18.5 over 37. What does that give me? I'm going to need people to crunch it. It'll be 0 decimal something. What is it? 0.5. Okay. Well, I'll let you in on a secret. If it works for 2 sides, then they are similar. Should we try our 2 shortest sides? So, shortest on this guy, 12.3. That's why we had to order numbers in our last one. Shortest on this guy, 25.83. Let's compare those two. FE over GH, 12.3 over 25.83. What does that equal? Sydney?
0.476190.
Okay. Those are close, but are they the same? You could round, but it's got to be perfect to be similar. I know. So, are they similar? Nope. So this tells us 1 and 2 are not similar. Maybe I sneak that in, number 1 and 2. So we got to try again. Which 2 do you think are similar? 1 and 3. Okay. So we're going to ignore number 2. What is we started with the shortest side. Is that what we did? The longest side. Okay, longest side on number 3 is 55. Oops, and I did that in the wrong color. Okay, so we want to compare. Do you want to put triangle 1 on top? So DE over AB, 18.5 over 55.5. I need you to crunch that for me. What is that one going to give me? 0.3 repeating. Well, we may as well do our shortest side next. I'm seeing that the shortest side is 36.9. So again, we're still going to do FE, because that one we said goes on top, it was first. Over, in this case, it's CB or BC. Doesn't matter how you write it. 12.3 over 36.9 is 0.3 repeating. If it works for 2 of the sides, bingo bango, you're in the money. So if it's the same, what did you just prove? Which 2 are similar? 1 and 3. So number 1 and number 3 are similar. Okay, flip the page. We're almost there today. 2 questions. I want you to try this now, showing your work, organizing your work. We have two similar triangles here. Your job is to prove to me that they are. We don't just guess. That's what justify your answer means.
Yeah, I don't have that page.
You don't have this page. What's your next page? What? This one? Okay, I guess we get to skip that one. It would have been fun, but, well, by understanding corresponding angles and side ratios, you can use that information to actually help you solve for a missing side. What that means is if I find the scale factor, can I just use that scale factor? Yeah, we started today with scale factor equals. What over what?
Image over original.
Okay. We have to use the sides where we know both.
3 and 6.
Good. Which one do you want to be the image?
3. 6.
6. So I'm going to say this is my image. This is my original. So if I say it's 6 over 3, what's the scale factor?
2.
2. Does that make sense? Is 3 times 2 going to give me 6? Well, if 3 times 2 gives me 6, how can I find out the missing side? 9 times 2, which means my mystery side is going to be 18 what? Centimeters. So, comes back to, is it all about our scale factor? Okay, I think you have one more. I don't. That's weird. Let's do it right here. Do you have a triangle? Yeah. Oh, do you want me to teach you the other way to do this? I probably should. Does yours say the whole cross, multiply, and divide? If you're going to do this, because sometimes they get harder, I am happy. I'll just wait till the side conversations. If you find me the scale factor, you show me that and you show me the multiplying. The other way you could do this is go small shape over large shape, small shape over large shape with corresponding sides. If I look at the one that I know everything about, would you agree the small shape? I knew that one of the sides was 3. So I could do my 3 centimeters. What side did it go with? 6. Would you agree that's what we just used? We had small shape, large shape. Yes? Now, if I keep that the same, what's the other side on the small shape? 9. Do we know the one on the large shape? Well, we do now, but in the beginning, did we know? It was a secret. So I would then take the small shape, large shape. If I have this, we actually did this last week. Do you remember I said cross multiply, then divide? Which two are across? 9 and 6. What's 9 times 6?
54.
Good. What do I do with the 3? Divide. What's 54 divided by 3? X equals 18. Have you seen that value before? So that's your other way to do it. You either find the scale factor and apply it, or you can use your cross multiply and divide. If you're using cross multiply and divide, it's always small over large. If we look at the one more that you guys have, you have a big old triangle, true? Do you think I can draw it? Nope, not like that. I can't. Can somebody tell me what things we know on the big old triangle? Okay, so I'm seeing that we have a 10 and an 8, yeah? And I'm also seeing that we know that we have a right angle. And we have a 55 degrees. 2 right angles. Very good. Does it tell you anything in the words? It doesn't seem like we have a lot of information. It's saying from R to K is how long? 20 centimeters. So this is R, this is K. This is all the way is 20 centimeters. What does it want you to find? R to T. And T is right here. If you're doing this, you need to make 2 triangles out of your big triangle. Would you agree one will be small, one will be big? So what I'd like you to do, redraw these. I'm going to make my small guy. I'm going to make my big one. If they're not perfect, it's okay. They're for learning. I'm going to put in what I know. On the small one, I know that this is 8. And I know I wish I knew this guy. On the big one, I know this is 10. And I know that this is 20. We can do our cross multiply one. So remember, it's going to be small over big equals small over big. Now, the first small over big is the one where we know both parts. What corresponding sides are on the small and the big and we know both? 8 and 10. Now, we also know another side. I think it's on the big. What is it? 20. Does big go on the top or bottom? It goes on the bottom. We're missing the piece on the small. If I'm missing that piece, are we okay with how I labeled that?
Yeah.
If I'm missing that piece there, what will I do to get it? Good. 8 times 20 divide by 10 is x is 16. So if you get a question like this, step 1, draw your separate shapes. Step 2, small over big equals small over big. Label the one that you know both pieces and decide where your other piece goes. Are we okay with that? Okay. What I'm going to ask you to do is I want 19 minutes of work. If you flip to the next page in your booklet, you have an assignment. Question 1 should be lickety-split because it's angles. You have to figure out which one has the corresponding angles. Question number 2 is kind of horrible. You have to look at those shapes and look to see, do they look like they're proportional? Can a rectangle turn into a square? No. Just do your best. I know the diagrams are not the best. So it's just circling yes or no. I will take questions in a second. Flip the page. Question 3. Question 3 gives you a starting shape, and it says select the ones that appears to be similar. It also isn't great. Just choose the one that looks the best. But then question 4 is where you actually get into matching things, and then you get into solving for things. Does that make sense? Okay, you're going to work your way through. You're going to ask questions. We're now down to 18 minutes. Elena. Yeah. Aiden?